So here, this is the way that Passive House is measuring the external dimensions of a thermal envelope. It goes through the thermal envelope. Yeah, it's not using the external dimensions. Yeah, not the external finish is included in the dimensions. It's important. Yeah, that's not correct. That's not what Passive House is doing. And it's as well not using internal dimensions. Yeah, so be careful when you're setting your, like if you're using Flixio or so and you're doing the thermal bridge analysis yourself, be careful where it is measured and if it's set for external dimension or internal dimension. It's one of the typical mess ups that people do in the thermal bridge analysis. And then the values are flipping around and then we're getting wrong results. And it could actually be that actually the house is not performing, is performing worse than we actually calculated it. Using build-up measured will lead to a different thermal bridge value with a different heat transmission and leading to a bigger calculation error. So we don't want that. So now, why are external corners normally coming to negative situations? So the external corners are normally a risk for mold, but they're a bonus on the energy efficiency. These thermal bridges can be economically important if big. If there's a lot of that corners and they are significant, then it could have an economical impact on that performance. So then we actually need to take them in consideration. Then option one, that we're not entering negative thermal bridges on smaller than 0.01 watt per meter Kelvin into the thermal bridge is not working any longer, because from an economical point of view, we're now over designing our building envelope, and then it could be not economical any longer, especially really big project, tight project, that could be a thing to improve the performance. But normally I wouldn't do it. It's just a bit more safety in my calculations and gives me a bit more security. And what you're seeing here now, you see now, because we're using our external dimensions, yeah, in our Passive House calculations, the external dimensions of our thermal envelope, we are now actually calculating this twice. Do you see that? We calculated losses through that thermal envelope here. We calculated losses through here, and that's the reason that the thermal bridge value normally turns out negative. If this is now turning around an internal corner, so that the indoors has the external corner and the outdoors has the internal corner. Now, because we're using the external dimensions, we're only looking at this values. We're not looking at these values. This is normally the reason why it becomes a positive value. Internal corners are not a mold risk, and they're letting more energy through. So we need to put them into our calculation, and we need to put them in our economical assessment.